Hi, I'm Isabel Andrade, and I'm presenting a part of my research, which is the coal boiler district heating in the University of Canterbury. Currently, 6,000 tons of coal are used per year by a medium temperature boiler to provide heat to the whole campus. As you can see in the pie chart, coal represents around half of the energy used in campus. The system consists in a main boiler house, which distributes the hot water to the different buildings in purple. Water leaves the boiler at 113 degrees, and it feeds the buildings through heat exchangers, and the water returns to the boiler at 70 degrees. Now, I'm going to run you through the InTIME methodology, and I hope it's not too long for you. First, we start defining the wicked problem, and we have an essential need, which is space heating, and it works great. The system is reliable and it's affordable, but it's not sustainable. It satisfies needs as it is on-demand heat, but it causes harm to the environment as there's pollution, coal mining. So we know it must be changed, but we also know that it's going to be very expensive. Some history. The original buildings were heated with coal in open grates for individual rooms or shared spaces. So in the picture, you can see there's some, well, the chimneys, a few of them. That means that we had a distributed heated system. In the 1960s, buildings used high temperature steam boiler in the new campus in Ilam, and then it was switched to medium temperature boiler in the 80s. This is how the university looks like right now. And business as usual, we have a growing demand as there's growth of campus. There was a consultancy company that was hired by the university to address the boiler issue. And in the report, they suggest that it should be a change from coal to wood chip. Now, the downside of it is that there's a need of a brand new boiler, as the current one will not operate with wood chips, and that we will need around 2.5 times more truck trips to deliver the amount of fuel required. Now, in the InTIME methodology, and for the forward operating environment, we know that 80% downshift in emissions needs to be achieved by 2040. So that's the initial engineering requirements for this project. In the future, we travel 100 years from now, and what do we find? We find a University of Canterbury that is a leading university with no coal boiler and reforested land, wood product revenues, waste wood heating fuels, with new buildings and some retrofitted buildings, but with high thermal efficiency. There is a heating system, but it will only provide the essential heat. So it's not going to be comparable as the 100% comfort required by the ASHRAE standards that are currently used. There will be a chance for the workers to manage their own environments. So that's going to be something that maybe at the moment we don't have. The aim of this engineered system will be able to provide essential heating in order to keep the work productivity. So as you can see there, we will still have those shoulder seasons, spring and autumn, where there will be cold days, and of course winter, but we will be able to manage those times where there are cold days in warm shoulder seasons. You can see there's a robe, and that comes from the idea that in the past, academics used to wear these beautiful robes with um, long sleeves to keep them warm. I'm going to talk to you about that in a second. The trigger is this shift project that engineers this 80% downshift. So we start by applying the constraint, and then we help adapt the current system to the requirement. Um, so it goes like, the next year you will have 80% less coal. What do you do? Now, the idea, and we propose to, it's to shut down the coal boiler over the shoulder seasons. And for that, we need to do some energy audits of the buildings, and we need to design a new adaptation program for workers. So it's going to be designed to achieve this 80% reduction in carbon emissions. The adaptation program for the workers is tailored for each worker, and it will include a few items and ideas. For example, a UC branded merino robe for academics, and a service to get them cleaned in time, and so that the robes can be ready for the academics in their offices to use. We propose UC branded merino lap blankets for those cold days, and some electric heating systems for workers. So it will be a special design to warm up the local space that the workers are using, instead of heating whole big spaces. We will promote and provide the opportunity to have active work spaces. And this means there will be available for the use of academics some standing desks, and also there will be the infrastructure suitable for walking discussions or walking meetings, as we will call them. And also we will provide the adaptive opportunity to work from home, for example, if there's super cold days. And even we can include in the design some long holidays for those super cold weeks. This was the whole InTIME methodology in a nutshell. So I think there will be questions, and I'm happy to address those in a minute. Thank you very much.